And never forget, if one side of a right triangle is unknown, how can we check our work? Drum roll. That's right, Pythagorean theorem. All right, so what does this look like? You've got some corollaries to the geometric means. It's basically what we've just gone through and looked at together, right? H squared is the product of x and y. A squared is the product of x times the entire length. And B squared is the product of this side times the entire length. What does that look like? Well, I want to do problems 12 and 15 for you, and then I'm going to leave you on your own to do some other problems. So in this one here, what sides do I know? Well, in number 12, let me switch over here, and I'll try to speed this up. So this is h. So h squared equals x times 3, right? These two. So this is the square root of 6 squared equals x times 3. Square root of 6 times the square root of 6. You're right, that's 6 equals x times 3. I can divide by 3. And I get x is equal to 2. Well, the reason that is so helpful, x equals 2, is now I have enough information to go around the rest of the triangle and figure out the missing sides. Because the full length here now, if this is 2, that means the full length here is 5. So y squared equals 3 times 5. Y equals the square root of 15. And last but not least, the same thing with z. Z squared equals 2 times 5. So 2 times 5 is 10. Z squared equals 10. Take the square root. Z equals the square root of 10. I've now just solved all the missing sides. Because of the time of the video here, I'm actually going to pause that. You probably want me to do another example. All right, I'll do another example. Let's do number 15. I'll change colors. So number 15, 18 squared equals 27 times x. Well, 18 squared, better hurry up here, clear. 18 squared is 324. And I'm going to just divide that by 27. Divided by 27 is 12. X equals 12. Well, now that I know that's 12, the full length of this side is 27 plus 12 is 39. Well, y squared equals 27 times 39. And then I would take the square root of that. And z squared equals 12 times 27, right? And then I would take the square root of z of 12. Uh-oh, my board just died. Probably because I'm pushing the envelope here. All right. So again, z, I'm going to take the square root of z squared. And the square root of 12 times 27. So 12 and 27, this is really 3 times 4 times 3 times 9. Oh man, I can pull out a 3. The square root of 9 is another 3.
Korea.
The square root of 4 is 2. So z equals 3 times 3 is 9 times 2 is 18. So I know this one. Boy, try following all that work. X equals 12. V is 18. And y, 27 times 39. That might end up, this would be 9 times 3 times 3 times 13. So that would be, take a 3 out, take another 3 out, square root of 13. So that would be 9 square root of 13. Oh, 9 square root of 13. Sorry for that confusion, but you can also follow the example in your book on how to do these. And Yeah, continue on there. So try the other problems, 13 and 14, and I think there's another problem missing there as well. The last problem here is I want you to try to actually apply this information, right? If I know this length here, I know the entire length here, I should be able to figure out that length with a little bit of subtraction, and then I can determine exactly how high the helicopter is over those two. The last part of this thing we need to work on is complete each equation. So what in the world are they talking about? Okay, well here's my diagram, and they're saying E over B, okay, so this is the long leg over the short leg, all right, is something over E. Well, we've got to be talking about the long leg over the short leg. So this value here has got to be C, because I'm saying long over short better be long over short. And take a look at each of these other two and say, wait a minute. All right, in this one, D over BC. Okay, well then this I'm talking about, this is the big triangle. D over BC, so this is long leg over hypotenuse. Long leg over hypotenuse. Better be the long leg over the hypotenuse. Well, A is the hypotenuse of the small triangle. What's the long leg of the small triangle? See if you can knock out those problems as well. This is the missing problems from before. I'm just going to scooch that up. And when you're done and do your honest to goodness hardest to try to figure out these problems, I've included the solutions on the next page. If you get stuck on any of them, you can't figure out where the answers have come from, please bring those questions up at the beginning of class on Friday, and I'm happy to go over any of those problems with you. Here they are. Voila.